Los Alamos National Lab is a national security lab. It has missions in nuclear weapons, in global security, and science serving society.
The Seaborg Institute is a national center for education on transactinium science. Our research into actinides is unique because there are very few institutions in the world that enable actinide science in general.
Actinides, especially uranium and plutonium, obviously important to nuclear weapons. They are materials important to global security. They are primary fuels for nuclear energy, and some of the isotopes have recently been used to cure cancer.
We are pushing the response of actinides to extreme conditions, and therefore we're really pushing our understanding of the 5F electron physics beyond our current understanding.
There's been a renaissance in the understanding of the fundamental properties of plutonium. Understanding those properties is essential to understanding the operation of nuclear weapons in the absence of underground testing. One area that the Seaborg Institute has supported is the development of resonant ultrasound spectroscopy.
Resonant ultrasound spectroscopy is thermodynamic susceptibility that allows you to look into anything that is coupled into the lattice. Anything like magnetism, superconductivity, radiation damage, defects in the lattice, you will see it. Of course, I study plutonium. In particular, I look at how plutonium changes as a function of time. Resonant ultrasound is very sensitive. So in a fairly short amount of time, I can see how it's evolving. So that tells me a lot about how it will be in the future.
Plutonium, with a 25,000-year half-life, which doesn't change very fast, we can watch this material age in a matter of hours by watching changes in its mechanical properties with part per billion precision, and that is one of the most important qualities of resonant ultrasound spectroscopy.
Learning all the components you need to have is very important. From the point of view of national security, we need to know how plutonium is going to be behaving 50 years from now, 100 years from now.
This team and the tools that it's been able to utilize and generate has provided us with a unique predictive capability for the aging of plutonium.
The tremendous improvement in the understanding of plutonium that's occurred in the last year is intimately connected with magnetism.
Magnetism has been very controversial between experimentalists and theorists. And for the first time, our theoretical models are now showing that the role of defects can induce magnetism and are becoming a lot more important than expected. I do density functional theory calculations, which is a method to be able to describe the electronic interactions of atoms in a lattice. By using Los Alamos National Laboratory's computational abilities here, we are able to find fundamental physics in plutonium that can relate back to resonant ultrasound spectroscopy.
The Seaborg Institute has grown from a niche function at the lab to now the most important recruiter of actinide scientists or scientists who wish to work in actinides.
We are working to train the next generation of bright scientists and research technologists with the expectation that this generation will take on this mission into the future.
My PhD advisor told me to apply for a Seaborg Summer Graduate Student Summer Fellowship, and I did, and I got accepted, and it was an amazing opportunity in the fact that I was able to engage with world experts on plutonium science.
The future is the people. And the people who are going to be in the future are the people that are starting right now. The postdocs that are coming with new questions to ask to plutonium, because if we ask the right question to plutonium, we might just have the right answer.
The need to make sure that we have the very best minds solving national security problems has produced an atmosphere of freedom to explore a very wide range of research topics at this laboratory. It is exceptional. So our mission is to find those really bright people, bring them into Los Alamos, so that when the global security and the weapons missions need really smart people, they're here.